All right, this lesson, this particular lesson 1-3, or this section, it's called polynomials, and polynomials are basically just, for instance, like 3a would be a polynomial if I have two things that are multiplied together, or even two things that are added together. But this right here is a one-term polynomial. We call it a monomial. I'm not going to be real picky on this, but these are numbers. These are words that should be familiar to you. Would you agree? That's a monomial because it's acting as one. I don't know exactly the best definition for this, but what I would say is if they're separated by a plus or a minus, see that's one term right there, that's a term right there, they're separated by either plus or minus. This would be two terms, and that would be a binomial. This is one term, it's a monomial. So you could have stuff like this. I mean, you could have 3x squared over y to the fifth. That right there is still a monomial, right? Because it's not separated by anything else with a plus or minus. But if I did this, if I did 2x z cubed over, I don't know, p or something like that. Look, these are two monomials, but you're adding them together, so really this is a binomial. You with me? All right, that's all I'm going to say about that. And if you had three terms, it wouldn't be a binomial. What would it be? Trinomial. Good. All right, so let's go through some basic rules for polynomials, and these are rules that we talked about in the other book. So it should sound like a lot of repetition, but that's okay. Do you remember this rule? If I had x to the a times x to the b, the bases are the same, right? This has to be true, and they're being multiplied together. So the rule says when you multiply together and you have the same bases, what do you do with the exponents? Add them up. Keep the base the same, you just keep the base x, then you just add those up. So that would be a plus b, correct? If you put some actual numbers in there, so like x to the third times x to the fourth, what is this? You keep the base the same, and what do you do with the exponents? Add them up, x to the seventh. Alright, pretty simple, right? Let's do one a little bit more complicated. What if we had this? 6z to the fifth, straight from the book, page 26. And then you had, they put these in parentheses. I'm just going to put a dot in between. Is that alright? Looks a little messy in parentheses. Like that. That's a cubed. And then 2z squared. 2z squared. Alright. Yes, to the fifth. Alright, so look at this. A lot of people, for whatever reason, what was I going to say on this? Forget what I was going to say on this. What was I going to say a lot of people do? That's okay. I think what they do, a lot of people forget, this is what I was going to say. A lot of people tend to forget this. This is actually a multiplication problem. Right? They look at the addition and they think, oh, it's an addition problem. It's not, is it? It's a multiplication problem, but the rule says, what do you do with the exponents? You add them up. So some people would do this, 6, 9, and 2. They add those up, but you don't. It's a multiplication problem. This is just a regular 6, right? It's a coefficient out in front. That's a 9, that's a 2. They're just regular old numbers. They're not exponents. So you don't add those numbers together. What do you do with those? You multiply them together, okay? So this is multiplication. 6 times 9 is what? 54 times 2, double 54, what is that? 108. So you can do that without a calculator, can't you? Now look at the z's. Z to the fifth, z to the third, z to the second. They're the same bases, aren't they? They're being multiplied together, so you keep the base the same. Now what do you do with these exponents? Add them up. 5 and 3 is 8 and 2 is 10, so it's z to the 10th. Makes sense? Okay. See what else. Okay, that's it for that. Let's do we'll do some more, all right? But they jump to this this rule right here. If I had a to the 0, now we talked about this in the other book, didn't we? What's anything to the 0 power? It's equal to what? It's a 1. Anybody ever show you why in the world that's equal to 1? Let me show you. Well, actually, let's do another rule first, then we'll come back to this. Remind me, okay, to come back to this. I don't think they do it in here. No, they don't. Let's go to this rule first, though. Watch this. What if you had x to the a divided by x to the b power? Do you remember the rule for this? That's right. You keep the base the same, and then you subtract the exponents, the top being the first one, so it's a minus b. You always go the top minus the bottom. Everybody see that? So that's your rule. Let's put an actual number in there. So x to the, I don't know, fifth over x to the second, x squared. Alright, so again, what's the rule? Keep the base the same, subtract the exponents. 5 minus 2 is 3. Alright, some people get a little bit confused when you start throwing some negatives around. Alright, so make sure we understand this. The base is the same, correct? So we subtract the exponents. It's negative 5 minus 3. If you need to, go off to the side and actually write it out so you can see it. Alright, because sometimes people get confused if they just try to subtract like this. So negative 5 minus 3 is what? It's negative 8. So it's x to the negative 8. We okay with that? Alright, now that you know this rule, let's go back to this right here, and let's figure out why a to the 0, or anything to the 0, x to the 0, anything to the 0 is equal to 1. What if I did this? What if I said x to the 5th over x to the 5th? What's the rule? By the way, what's anything divided by itself? It's equal to 1, isn't it? So would you agree that this eventually is going to come out to be a 1? Yeah. Okay, anything divided by itself is 1. But I want you to see why this is 1. Do you see it already?
Yeah.
Okay. That's right, because you keep the base the same. What do you do with the exponents? You subtract them. So that's x to the 0, isn't it? Alright, so anytime you have the same thing on the top and bottom, it's going to be x to the 0, because it's the same, it's one number minus the same number. Alright, so x to the 0. And again, what was x to the 5th over x to the 5th? It's a 1. Now do you see why x to the 0 is equal to 1? Alright, that's not hard to see, right? It's not that difficult, but some reason teachers leave that out and they just say, okay, this is true, boom, that's it. Even the book doesn't even show you why that this is true. Yeah, I'm looking, I don't even see it at all. Alright, but don't you think they should? I do. Alright, let's do another rule. I'll get rid of this. Give me some room here. We're going kind of quick because you've seen this before. You actually saw this in Algebra 1, didn't you? And then you probably didn't see too much of it in geometry, but then you saw a ton of it in Algebra 2, and we've already seen a lot of it here in that other book that we were using. Yeah. Where is that? 1.6? Right. But in this rule, and right here, when they first introduce a to the 0 equals 1, they don't show you. I think they should show you right here. But thanks for finding that, because I kind of figured that they would. I was surprised not to see that. But what page are you looking at that? 54. Oh, so they don't even show you that division rule until section 1.6. I just kind of figure we'll put it all together. All right, makes sense, doesn't it? So I apologize to the writers of the book because you know what I would do, that a to the 0, I probably wouldn't even introduce that until I showed the quotient rule, and then I could go ahead and say that. But I didn't write the book, and I don't ever want to write a book, so let's do this one. What if you had x to the a, and we took that whole thing and we took it to the b power? Now again, we've done a lot of these, so you should recognize what it is. What happens when you take an exponent to another power? You multiply those exponents together. You keep the base the same. I've been saying that a lot, haven't I? Alright, sometimes it just bounces off you, but listen to what I say that for a reason. You keep the base the same, and then you multiply the exponents. What's a times b? It's just ab. Let's put some regular numbers in there. I don't know, x to the 5th to the what? 4th? Okay, keep the base the same, and what do you do with the exponents? Multiply them together, so it's x to the 20th. It's as easy as that. Make sense? Let's do one a little bit more complicated. What if I did this? What if I did 3 to the 6th to the 5th? What did I say? What about the base? Keep the base the same. So I just keep the base to 3. This time it's an actual number, isn't it? It doesn't always have to be an x. Alright, the base could be a number, because x stands for a number, doesn't it? It's a variable. It represents a number. So we just happen to throw an actual number in there. So you keep the base the same, and what do you do with the exponents? Multiply them together, so it's 3 to the 30th. And you just leave it like that. 3 to the 30th is some outrageously large number. I'm not going to write the whole thing down. In fact, Jude, it probably comes out to an exponential, doesn't it? Probably says something, point something, a whole bunch of stuff to the whatever power. Yeah, because it's a gigantic number. So you just keep it like that. Okay.
Show you one where you have the original 3 to the 6th and then 5th outside and then time another one?
Yeah, we can do that. We're going to actually do that right now. Where was that? It's right. Well, kinda. They're going to kinda do this. I'll show you this. Watch. This is right from the book. 3 to the 4th x squared. But then that's in parentheses, and you got a cubed on the outside. Now look at this. Everything in here is being cubed, isn't it? So if you could kind of do this in your head, I guess, but I'm going to show you this step. You might not have to write this down, but I'm going to show you. So what we do, this is acting as one number right there, 3 to the 4th. Okay, I'm not even going to figure it out. I'm not going to figure out what 3 to the 4th is. It's really not that hard. It's 81. But I'm not going to worry about that. I'm just going to write it 3 to the 4th. But what are we doing? We're taking it to what? The third power. Okay? So it's 3 to the 4th what? Cubed. Do you agree? Now again, this is a step you might be able to just leave out if you're actually doing the problem. I'm just doing this for teaching purposes. Okay, so it's 3 to the 4th to the third power, and then what's this going to be? X squared to the what? Third power. You follow me? People look at it and they think it's distributive property. It's really not distributive property. Distributive property is when something's being multiplied, right, and you have a plus or minus in between. That's distributive property. This is not. This is just taking everything in the parentheses to that power, to the third power. Okay? Again, this is a step you probably could leave out, but it's kind of what's going on in your head. See, that's your brain right there. Okay? That blob. That's what's going on inside your brain. Alright? So what's this going to be? It's going to be 3 to the what? 12th. And this is going to be x to the what? To the 6th. Good. And just leave it like that. There's no reason. 3 to the 12th is even a pretty big number. So I wouldn't simplify it. Now, what if you had like 3 to the 3rd? I wouldn't leave it 3 to the 3rd. What's 3 to the 3rd? It's just 27, okay? So, you know, where is the point where you leave it and when you actually simplify it? I don't know. Whatever you think, okay, is that point. I think that's too big to worry about. It'd be a super big number. I'm just going to keep it 3 to the 12th, okay? All right, let's do another one. So watch, we got 2 to the 5th over b to the 4th. And that whole thing is to the third power. Now this time you have a division, but it's the same kind of deal. Do you see how we took this to the third and then this to the third and multiplied them together? Same kind of deal, isn't it? This is 2/5, or not 2/5, 2 to the 5th, right? To the third. Let's leave this part out when we write it down. Let's actually just do it in our head. What's 2 to the 5th to the third? 2 to the what? 15th, right? Because the rule says we multiply the exponents. Over, right? Now, do the same thing with the bottom. It's b to the 4th, what? To the third power, right? We're taking everything to the third. So what's that going to be? B to the what? 12th. That's it. That's all you can do. You can't simplify it. Don't try to look at 12 and 15 and say, oh, 3 goes into it. No, you can't do any of that stuff. You just leave it just like that. That's all you can do. Does that make sense? Okay. Let's pause this. All right, here we go. A little bit different, but we're still working with polynomials and exponents and bases and all that kind of stuff. All right. Look at this. Do you remember this from Algebra 1 and Algebra 2? So I'm not going to go as basic as I could if this was an Algebra 1 class, but you remember that when you add things together, you can only add what? What was the phrase? Like terms. Good. So you can only add like terms. Now, there are parentheses around this, but really, are the parentheses really even necessary? Not really, because you're just adding the stuff in here. You're not distributing anything, are you? So I would say the parentheses aren't even, I'd say the parentheses aren't even needed. So let's just get rid of them just to kind of clean it up a little bit, see what's going on. Now, what we're going to do is add the like terms. Which ones are like terms? Well, y to the 4th, is that a like term with y squared? No, it's got to be the same. Now, the number out in front can be different. We call that the coefficient. That can be different. It's the variable and the exponents have to be exactly, dead on exactly the same. Okay, no more, no less. So this is y to the 4th. What else? This is y to the 4th. Add them up. 2 of these plus 4 of these gives you what? 6y to the 4th. Do you add the exponents? No. A lot of people do that. I like to cancel them out when I'm done with it, so I know I'm done with those. Let's do the next ones. Y squared and y squared. So it's negative 3 plus 7, which is positive 4y squared. I'm done with those. This is a plus y and a 6y, which is plus 7y. And there it is. That's all there is to it. Okay? All right, we got more to do on section 1.3, but we got a good chunk of it done.